Hello class, today we are going to talk about similar right triangles. All right. So here we go, and before we get into similar right triangles, we're actually going to talk about geometric mean. Yeah, so geometric mean, what is that? The geometric mean of a and b is x, such that a over x is equal to x over b. So this is not the arithmetic mean. What you've been doing all your life is the arithmetic mean, where you add all the numbers and you divide by however many you are, right? However many you have. This is the geometric mean. This can only be done between two numbers, a and b. And what it is, you set it up into a proportion where a over x equals x over b. And this x, that's your geometric mean, all right? So, for example, we want to find the geometric mean of 10 and 20. So 10 and 20, those are my a and b, doesn't matter which one's which. So we're going to put them into that ratio. So 10 over x equals x over 20. You cross multiply, so you have 10 times 20, x times x. So 200 equals x squared. You don't want x squared, you just want x. So you got to get rid of that square, right? You undo squaring with a square root. So we need the square root of 200, which doesn't have a nice pretty square root. We're going to simplify this really quickly. Where did I put it? Right there. So the square root of 200, this is where we do that factoring thing. So let's see, what multiplies to get 200? Well, that's easy enough. That's 100 times 2, right? So we have the square root of 100 times the square root of 2. And the square root of 100 is 10, out from under the square root. 2 is prime, so it's done. So we have 10 and the square root of 2, and that's our answer. 10 square roots of 2 is the geometric mean between 10 and 20. And do one more really quickly. So the geometric mean of 7 and a is 13. We want to find a. So this time they're telling us what the geometric mean is, and they're giving us b. All right, so the geometric mean, that's our x. So it's going to go in both ratios, and then the 7 is going to go on the bottom. So we have a over 13 equals 13 over 7. Cross multiply and divide, right? So it's 13 times 13 and a times 7. So that gives me 7a equals 169. Divide both sides by 7, and a is 24 and 1/7. All right, not too big a deal. Now, real quickly, you can shortcut this. Like I said, we cross multiply this, right? So that gives us ab is equal to x squared. And so if I'm just looking for the geometric mean, what that is the square root of the two numbers, the square root of a times b. All right, so over here, it's the square root of 10 times 20. All right. If you're looking for a or b either way, you just take your geometric mean, you square it, and you divide it by the number you have. So a is x squared divided by b, and b is x squared divided by a. So you can shortcut it a little bit. All right. And that's geometric mean, and now let's look at our right triangles. So let's take a look at this right triangle, because that's what we were going to do. We'll talk about similar right triangles, right? So what I'm going to do is I'm going to take this right triangle ABC, and I'm going to draw the altitude from A to segment CB. All right, remember the altitude, it goes from a vertex perpendicular to the opposite side. And what this does, this divides the triangle into two more triangles, right? So I have this little triangle, I have that little triangle. I'm just going to go and break those out right over here. There's the one, there's the other. All right. Now, on these triangles, well, they're both right triangles, and if you'll notice, angle C is the same as this angle C, right? I can just bring that over there, and you see they're the same thing, right? Because that's where I got this angle C from, was just this angle C. And over here, angle B is the same as angle B, right there. Which means, all three of these triangles have angle-angle similarity. Right, because I have angle C matches up and the right angle matches up. Over here I have angle B matches up and the right angle matches up. So we have angle-angle similarity for all of these. So my triangles are similar, which means I can write a similarity statement. We want to do that. So here I have triangle ABC is similar to triangle DAC is similar to triangle DBA. Notice the order here. I started with my original with angle A. Well, angle A is the right angle. So for the green triangle, I need to start with the right angle because it's got to go in the same order. So the right angle is A, it goes first. So here the right angle is not A, that's acute. The right angle is D, so D needs to go first. And then angle C is congruent to angle C because it's the same angle, just moved over. Well, let's see, C went last, and so I need C to go last, which puts A in the middle. And over here on this one, on the pink one, again, the right angle has to go first because that's what I put first in the blue one. So that's angle D, and then angle B is angle B. So angle B and angle B go match up. Well, B was second, which means over in the pink one, B needs to go second, so A goes last. All right. You got to pay very close attention to the order here. Make sure you keep that straight. And it can be a little confusing, I'll admit. So just take it. Easiest way to do it is first match up the right angles, then match up whichever one it was that you moved over. That's the exact same angle, and then your third angle is just going to be wherever it goes. All right, so for example, just so you can see this, let me grab this and flip this about like so. And you'll see that angle A is the same as angle B there. All right, so angle A matches up with B. And I could do the same thing here. This angle A matches up with that angle C. Okay, so I want to find the length of segment CD. Well, segment CD is, I don't know, it's not 65. The 65 is the length of this entire side right here. That's the 65. Right? I just want CD. Well, since these are proportional, I can set up a proportion. There we go. So I'm going to start with what I know. I know 56. I'm looking for CD. So 56 over CD equals, well, let's see, in this blue triangle, which side is going to match up with AC? It is not AC. If you'll notice, AC in the green triangle, that's the hypotenuse, right? AC in the blue triangle is not the hypotenuse, so they don't match up together. Let's see, so what does match up with the hypotenuse? Well, the hypotenuse, that'd be 65. 65. Well, then what matches up with CD? Well, let's see, CD is the long leg here, so I want the long leg in the blue triangle, which is 56. And so I have 56 over CD equals 65 over 56. Notice I have 56 in both ratios. This is the geometric mean. That's why I showed you geometric mean a minute ago. All right, so 56 is the geometric mean of the leg here, this long leg, and the hypotenuse. Well, okay, we're going to solve it. So what we do, we take 56 times 56, and we're going to divide it by 65. We're going to work this out. So we have 56 squared divided by 65. Where's my calculator? There we go. Turn it on. Okay, so 56 squared divided by 65 is approximately 48.25. Right? Great big long ugly decimal. I'm going to say it's approximately 48.25. So there it is. All right, where'd it go? There we go, 48.25. So now I have CD. Let's find DB. Okay, so let's see. We're going to set up our ratio again because we have similar triangles here. So we are going to start with the side I know over the side I'm looking for. So 33 over DB equals, okay, and over here in the blue triangle, what matches up with 33? What matches up with our AB? It is not AB. Because once again, you'll notice in the pink triangle, AB is the hypotenuse, which means from the blue triangle, I want the hypotenuse, because the hypotenuse matches up with the hypotenuse. So I want 65 to go on top. There it is. And so DB is, let's see, in the pink triangle, DB is the short leg. So the short leg from the blue triangle is 33. So there it is. And notice I have 33 over DB equals 65 over 33. Again, I have this geometric mean. So this segment right here, DB, this leg is the geometric mean between the hypotenuse and this piece of the hypotenuse. There it is. So, not too big a deal. We're going to multiply this together, 33 times 33, and then we divide by 65, like that. So, get my calculator back out. And this time we want 33, nope, not that. 33 squared, there it is, divided by 65 is 16.7538, on and on. We'll just round to the nearest hundredth, and so 16.75 approximately. Right? Now, there is a faster, easier way. We could have done this. What we could have done is, you know what, the entire thing for CB is 65, and I know CD is 48 and a quarter, so you could have just subtracted them. That works. It's fine. But I wanted to show you the geometric mean again. Okay, so there's that. Now let's find AD. What is the length of the altitude for triangle ABC? Well, we can't figure it out from this, but I can figure it out from either one of these. I could use the green one or the pink one, either way, and I could find the hypotenuse. So I'm going to set up a proportion, and I'll use the green one because why not? So let's see here. We have 56 over AD. There we go. And in the blue triangle, what matches up with 56? Well, as we said, that is the hypotenuse there, so 65. And what matches up with AD? Well, this time AD, that is the short leg. So the short leg here is 33. So there it is, 33. And we do our cross products here. We're going to, there we go, cross products. Pull up my calculator, move that over a little bit so I can see what I'm doing. And I have 56 times 33 divided by 65. And we get 28.43076 on and on it goes. Okay, so there it is, approximately 24.43. Now, we could do this another way. I could use, since AD is in both the pink and the green, I could use the pink and the green. So here, instead of using the 33 and the 56, you have to use something that you have for this. We could use DB and CD. All right? And the reason for that is AD is the short leg, and so I need to use the short leg over here, which is 16.75. Here AD is the long leg, and so I got to use the long leg over here, which is this one. So I'm not going to be using the hypotenuse, even though I have the hypotenuse for both of them. It's no good. All right, so we're going to set up our ratio. So AD over 48.25 equals, well, AD over here doesn't go with AD. You're not going to have AD on top of both of them. AD is the short leg, so I need the short leg, 16.75, and then I need the long leg, which is AD. All right, so again, you see geometric mean. All right, so the altitude is the geometric mean for these two pieces here. Okay, so we're going to put that in here, and we're going to, basically, we're just going to multiply those together, and we take the square root, right? Because these two, and then over here we have AD times AD, so AD squared, or we just want the square root of it. So let's take a look at that. Move that over here. Okay, so I want the square root of 16.75 times 40, wait, that's a typo. That should be 25. I'll fix that in a minute. There we go, 25. So 0.25, and we get something that's very, very close, but not quite. Why don't these match up? Right? It should be the same thing. It's AD, it's the same segment. Why does it not match up? Here's why it doesn't match up. This number right here, the 48.25 and the 16.75, those weren't the exact answers, were they? No, the answers were right here, great big long things. Okay, we rounded, and because we rounded, the numbers are slightly off. So, for example, here we can do this. We'll just go up here and pull them. So 48, pull that, times the 16.75. And if I do it like this, now you notice these two are the exact same. All right? So rounding will give you wrong answers if you use rounded numbers. We don't really like to use them if we don't have to. Now, I do want to show you one other way we could have found AD, and that is, you know what? This is a right triangle. I know one side. I know the other side. I can use Pythagorean theorem. So I'm not going to put this all up there. I'm just going to show you. So Pythagorean theorem, that's a squared plus b squared equals c squared. In this case, I know the hypotenuse, so it would be c squared minus a squared equals b squared. So we want to take the square root of c squared, 56, squared, minus this number. But I don't want to use this one. I want to use the one that was not rounded. So let's see if I can find it. There it is. And square it. And I get almost the exact same number. It's off way down here in the tens, hundreds, thousands, 10, 100, million, 10. Yeah, in the 100 millionths place. It's off a little bit because, again, we've got some rounding going on way down there. So, a couple of ways you can get that. Could use Pythagorean theorem, but again, it's better if you don't use rounded numbers. So using the 56 here is more effective. I could have just as easily done it here. 33 over AD equals 65 over 56. All right, that also would work. All right, so important things. Geometric mean only works for two numbers. You can't use it for a bunch of things like you can the arithmetic mean. And it sets up in this ratio. A over x equals x over b. So the geometric mean is the square root of the two numbers that you're looking for, the product of those two numbers. Okay. Also, the geometric mean shows up when we look at these similar right triangles. Only works if you have the altitude drawn from the right angle, and it's going to split it up into two similar triangles. We have three similar triangles, and then we can use proportions. All right, is all it is. If you can remember geometric mean and how it goes, that's great. If not, just set it up in a proportion. Always use numbers that were not rounded if at all possible. Hope you found that useful, and I will see you in the next video.